Good evening, guys. Welcome to EdSofta. Um, we so we've been running a mini tutorial since two, and today what we're just talking about is physics. Yes, so that's what we'll be talking about since two, talking about different topics in physics. Okay, so the topic we have for today, well, for this section is projectiles. As you can see on your screen, lectures on projectiles. Okay, so but quickly before I start, so what is EdSofta? What is EdSofta? So yes, this tutorial is powered by EdSofta, as you can see boldly written on my shirt. I don't know if you can see my shirt, but you can see boldly written on my shirt, EdSofta. So I'm proud staff of EdSofta, and so EdSofta is a tech company that creates solutions to help people practice and prepare for various exams. And then currently on the market we have two: EdSofta UTME and EdSofta SSCE. So EdSofta UTME is an app that prepares students for JAMB UTME. It has past questions, study materials, and many other features that help students prepare for the exams. Okay, so for this tutorial, we'll be solving questions from the EdSofta app. So we'll go through the slides, talk on projectiles, and then when we are done, we'll solve some questions using the EdSofta app. So, okay, so sorry, if you want to, so you can have the EdSofta app on your phone or on your desktop. Yeah, on your Windows device, on your phone or on your desktop. Preferably the Windows, a Windows desktop or PC, anyone, laptop, anything. Okay, so if you want it on your phone, you can go to Google Play and then search for EdSofta UTME and just search for it, and then when it comes up, just install it. Then you would need to activate to have full access to all the features that we have put into the app. Okay, so then for if you want to store on your system, just go to our website, which is www.edsofta.com, and so click on products, and then when you see our products, see our list of products, or the products we have created, and then you can download one for desktop or Android. Okay, so let's quickly move on to what we have for today. Okay, so yeah, we'll take lectures or questions from the EdSofta app, and then take questions from you. We are at your service. Okay, so moving on. First thing we're going to be talking about is projectiles. Projectiles. So now, first question is obviously, what is a projectile? So a projectile is an object upon which the only force acting is gravity. If you are in school, when they teach you projectile, they would have drawn an arc of some sort to indicate how the trajectory of that object. So it's just an object that force of gravity is just acting upon. So when you kick a football, if you notice when people play when CR7 or Ronaldo or Messi, they step up to take a free kick. Now if you notice the trajectory of the ball, right? So you notice the ball curls over the wall and into the net. So that is just an example of how a projectile works. As an example of how a projectile works. Okay, so a fired bullet, a shot arrow, and a bunch of other stuff. Okay, so now because a projectile is moving at an angle to the horizontal. Okay, so if you were around in our earlier class, you would have where we talked about vectors, you would have seen where we were talking about how you resolve vectors into horizontal and vertical components. Okay, so when you tilt vectors at an angle, they are always at horizontal and what is it called, vertical components. So now, because the projectile or the item you are the projectile, yes, that's the, I think that's proper term for it. The projectile, that the trajectory of the projectile is always at an angle, right? So the trajectory of a projectile is always at an angle. Okay, so the trajectory of a projectile is always at an angle. Okay, so having said that, so this is how it looks like. Okay, and then it moves like this, and then it lands. Okay, so now this velocity here, can have a vertical and horizontal what component. A vertical, pardon my drawing, a vertical and an horizontal component. So because it is tilted at a particular angle to the horizontal, it can have what, a vertical and an horizontal component. Okay, so that's why, so you can resolve. And how do we get the vertical and horizontal component? So if you remember from our earlier class, which was the first class we had on vectors, you recall that, so we're using v as velocity on the horizontal axis, which is vx, is equal to v cos theta. If you watch the earlier videos, you understand how we came across this. Vx is equal to what? V cos theta. And Vy also, Vy is equal to what? V sine theta. Okay. Now, having said that, now there are a couple of things I'm very sure you remember, if you recall, if you've done projectiles before. We always calculate height, we always calculate time, and we always calculate range. But the thing is, we always cram these formulas. So I'm going to show you how these formulas were derived in the first place so that you would not need to cram any of the formulas. Okay, so we're going to start firstly with time. I'm going to start with what? Time. Okay, so now look at this. So I'm just going to erase this because I didn't very well. Okay. Okay, so now let me redraw it again. So this is what I have, and then goes like this. So now I want to know the time it takes to reach this point. I remember at this point is the highest that the projectile, maximum height, H max, that the projectile can reach. Now, if you remember this formula, which is literally a formula anybody that encounters physics knows first. You remember this formula, V is equals to what? U plus AT. V equals to what? U plus AT. V is equals to what? U plus AT. So now, sorry. Okay, so now, having said that, V equals to U plus AT. So now we're trying to calculate what? This time here, right? So now there's some things that we need to change. For example, we are working in the, what is it called? Because this velocity is in the what? So we're working in the what? The horizontal, sorry, vertical, not horizontal. The vertical what component? We're working with the what? With the vertical component. Now, As you notice, it starts with what? An initial velocity, right? So, and at this point, Vy becomes what? So, which is the final velocity? Vy becomes what? Vy becomes 0. Okay, so it starts off with an initial velocity, and then when it gets here, final velocity, so it stops accelerating at this point. So the final velocity is what? Is 0. So now, having said that, so this u also, if I were to resolve it to my vertical and horizontal component, so I'm going to have that ux is equals to what? U cos theta, and uy is equal to what? U sine theta. Okay, so I now have, so remember I was talking about the what is it called? The y component. So this will be y, this will be y. So Vy is 0 at this point, so it does not matter to us. Then what is Uy? Uy is equals to what? U sine theta. So I have what? U sine theta plus what? Gt. Now, and why is that? Because the acceleration, remember, we said that a projectile is a particle or an object in which the only force acting on that object is what? Gravity. So that means that's the only acceleration that it would have, the acceleration is the gravity. And now, because it is going against gravity, yeah, this would have been what? Minus g. So that means this would be what? This would be minus. This would be minus u sine theta minus gt. So now I'm trying to make t solve the formula, so I take minus gt to the other side. So what do I have? Gt equals to what? U sine theta. Okay, so I divide both sides. I divide both sides by g. I divide both sides by g. This cancels out. I have t is equals to u sine theta over. Oh, sorry. So I have u sine theta over g. Okay, u sine theta over g. Now, so now that's the time it takes it to what? To reach what? The maximum height. So, but I wanted to know the total time of travel. Now, because this thing is symmetrical, in the sense that the time it takes, so the time it takes for it to move from here to here is the same time that it takes for it to move from here down. So that means my total time, which I will indicate to the big T, is same as 2 times my small t, which now becomes what? 2u sine theta all over what? G. Period. So all you just need to remember is that for time, yes, for time, we're trying to, for time, we also use the formula V equals to U plus AT, and you can go from there. So I don't need to cram this formula. I don't need to cram this. This. Do you understand? I can always get it from what? This. Okay? Okay, so now this is how you get the formula for what? For time. So now the next question is, how do I get what? The height. How do I get the height? So now another thing that comes to mind is this. So you're looking for the vertical what? Height, not the horizontal height, the vertical height. So another thing that comes to mind is, remember this formula. V squared is equal to what? U squared plus 2AS. Okay? V squared equals to what? U squared plus 2AS. U squared plus 2AS. So we're trying to find what? We're trying to find what the height, which would be h in this case. So as right to respect to gravity, what I'll have is what? V squared equals to what? U squared plus or minus 2gh, because gravity could be plus or minus for all we know. So now we want to calculate what? The maximum height of this guy. So that means we need to make what h solve the formula. So now v squared, remember vy, and remember we're looking for the vertical height, so which means we're dealing with what the vertical component. So I remember vy vertical component of final velocity is what is 0 at this point. Okay, so that means we have what 0 squared equals to, so sorry, this should be uy also. This should be y because we are dealing in the y axis. So what that gives me is, this is my formula for uy. So I have what u sine theta squared. Now because it is going against gravity, I'm going to have minus 2gh. Okay? Okay. So 0 squared obviously gives me 0 equals to, if I find the square of this, I get what u squared sine square theta minus what 2gh. I take minus 2gh to the other side. I have 2gh equals to what u squared sine square theta. Okay, so I divide both sides by 2g. I divide both sides by 2g, and I'm left with h, which my maximum is equals to what u squared sine square theta over what 2g, and that is how they derive that. Okay, I hope that has been clear. So you can see how we're using the basic equations of motion, right? The basic equations of motion to derive these formulas. So it goes to show how like physics just keeps recycling. Like once we're dealing with motion, we're just recycling the same formulas, just different ways. Okay, so now the last guy that we're going to be talking about here would be range. So now range is what, when we say range, we're talking about what? The horizontal distance. The horizontal distance. And now normal horizontal, so remember this formula, speed is equals to what? Distance over time. So if I make this as the formula, I have distance equals to what? Speed times time. Right? Okay. So now, having said that, so since when we are talking about projectiles, we're always dealing with what? The vertical component. So this is my speed here, represented with this u sine theta. So this can be written as what? U sine theta times time. And remember, we what is it called? We have, oh sorry, no. What am I saying? Yeah. Now we're looking at the horizontal. Yes, we're looking at the horizontal. Remember, I said range is what? The horizontal what distance. So that means we're going to be using what? The x. We're going to be using this guy. We're going to be using this guy here. Okay, we're going to be using the x component of our speed, because this means we're doing what? The x component, because we're doing finding the horizontal distance. So h is what? The vertical distance, range is the horizontal distance. So having said that, so I'm going to be using this as my speed. Okay, so u cos theta times time. And remember, we already calculated time here as what? U sine theta over what? Over g. So if I substitute that, what do I have? I have what? U cos theta times U sine theta over G. Okay, so let's continue this here. Okay, so sorry, thinking I could clear this. Okay, no problem. Okay, so if I continue, if you multiply, what do you have? You have what? U squared sine theta cos theta over what? Over G. Over G. And I remember from your trigonometry, so maybe this is from mass, where you have sine 2 theta is equals to where you have sine A plus, where you have sine 2A is equals to uh, oh sorry, why isn't our total time? Sorry, let's use our total time, not half time. I knew there was something missing. Just use our total time because at the horizontal distance is because we're calculating the horizontal distance, so the total time it takes for it to move from here and land here. So my bad. This should have been capital T. So let me just rewrite it. Okay, so this will be 2u sine theta over g. So this will be what? So remember, sine 2 theta is now equals to what? 2 sine theta cos theta. So I'm just going to replace this whole thing with what? Sine theta. So what I end up with is what? U squared sine 2 theta all over what? Over g. So these are our formulas. So I'm just going to let me highlight them with a red pen. Okay, so this is formula 1, this is formula 2, so this is another formula, and then this is the last formula. So this is our range, this is our height, this is our range, height, and then total time. And that is how the formulas for projectiles are defined. And that is all on projectiles. Okay, so yes. So okay, so yeah, I think that's all that we have on projectiles. So I'm just going to solve a couple of questions from the what is it called? From the EdSofta app. Yes. I'm just to solve a couple of questions from the EdSofta app. Okay. Um So I've saved a couple of questions. So this is another functionality that EdSofta UTME provides. You can save questions that you want to get back to later. So I've saved a couple of questions already. So so let's start from the bottom. Okay. So now, as you can see, it says the projectile is fired from the ground level with a velocity of 300 meters per second at an angle of 30 degrees to the horizontal. Calculate the time taken to reach the maximum height. Calculate the time taken to reach the maximum height. So, if you remember from our discussion earlier, okay, so let me just share that part of, let me share a part of my screen. So I'm just going to rewrite the formulas here again. So small t is equals to what? U sine theta over G, and BT is equals to 2U sine theta all over what? G. Then we have what? H is equals to what? U squared sine squared theta all over 2G. Sorry, I don't think I wrote that properly. Okay, so sorry for that breaking transmission. Yeah. Okay. So I'll just quickly go over what I did before. So what happened? What I did was this. Okay. So the question told us to what? To fire. The question says a projectile is fired from ground level with a velocity of 300 meters per second. 300 meters per second at an angle of what? 30 degrees and to the horizontal. And the question says calculate. Now, yeah, before I continue, always remember you have to pick the angle it makes with the horizontal, or the angle it makes with the vertical. So if you were told the angle that it makes to the vertical, you have to convert the angle to the angle it makes at the horizontal, which simply just means subtracting I am subtracting from 90. Is that clear? Okay, so calculate the time it takes or time taken to reach the maximum height. Okay, so actually, piece of cake. So as you can see here, we listed all our parameters, right? Okay, and then we plug them right into this. I'm sorry that this is blocking you, but this is meant to be. This is meant to. Okay, so yeah, t equals to what? U sine theta over g. So we just plug in all our variables. Sine 30 equals 0.5, 0 cancels 0, and 30 times 0.5 is what? 15 seconds. So that's just that for that question. So let's let me show you guys another question from the EdSofta app. Okay. Remember, this feature is called the Save, as you can see, Save Questions feature. So I saved a couple of questions, and then it shows it with the answer and the explanation, which are supposed to correspond with what I just said. Okay. Now, look at another question. A bullet fired vertically upward from a gun held 2 meters above the ground reaches its maximum height in 4 seconds. Calculate its initial velocity. Okay, this really is not that related to projectiles, but it's just this just simply is just a combination of normal equations of motion, right? So when you fire a gun vertically upwards, so that means when a bullet is fired vertically upwards from a gun, so that means the bullet is coming out with an initial velocity, right? Okay, so I think I have height, I have time, and I have g, which is my acceleration. So that means I think the best formula that would be useful would be S equals to ut plus half gt squared. Yeah. Or v squared equals to u squared. No, I think s equals to ut plus half at squared would be preferable. S equals to ut plus half at squared. So let's just go back to the board. Okay, so we're just going to solve it somewhere under here. So what are my parameters? I have height, as what, 10 meters, right? And I have time as what, 4 seconds. And I have acceleration due to gravity as well, 10. So the formula that has all this, and I'm looking for u, that has all this, and what I'm looking for is h equals to ut plus half gt squared. Now, remember, because it is going upwards, which is what? Against gravity, right? It's going against gravity. So my g here will be what? Minus 10. It is going what? Against gravity. So my g would be what? Minus 10. Okay, so having said that, so what I'm going to have here will be, so my height is what? 10. So 10 equals to u, which I don't know, times 4 plus half times minus 10, which is my gravity, and 4 squared. So 10 is equal to 4u plus 2 go here 1. I have what? 5, right? Minus 5. So minus 5 times 4 squared gives me 16. So 5 times 4, 20 times 4 as 160. So remember, I have minus 160 here instead of. I have minus 160 here. So I have minus, yeah, if you calculate that, 2 here 1, 2 here 5, and I have 5 times 16, 5 is 6, that's 0, remainder 3, 5, 80, sorry, not, it should be 80. Sorry, I made a mistake. It should be 80, not 160. Okay, so 4u minus 80. Okay, then I now have, I take 8 to the other side, so I have 10 plus 80 equals to what? 4u. and then I have 90 is equal to 4u. Divide both sides by 4, and my u. 4 in 9 is 2 remainder 1. In 10 would be 2 remainder. Sorry, let me confirm what I'm doing here. So my height is 10. Oh, sorry, my height is 2. I knew that would not move. My height is 2, not 10. Sorry. My height is 2, not 10. So let me just correct that. I knew there was a problem because so my height is 2. So I have 2 here. I have 2 here. Okay. So I have 2. And just to confirm, my time also is what? Is 4. Yes. So it's vertically upward from a gun held 2 meters above the ground. Held 2 meters above the ground. Okay. So then when I continue, so that means this becomes what? 82. Then I have what? Oh, wait a minute, guys. Now look at let's look at this question very well. I'm coming. Let me project this question because we're getting a decimal and we are not supposed to get a decimal. Okay, so let's look at this question properly. Okay, so now it says a bullet fired vertically upward, yeah, from a gun held 2 meters above the ground. Held 2 meters above the ground, reaches its maximum height in 4 seconds. Okay, so now what I'm getting from that statement now is that we don't know the maximum height actually. Yes, we do not know the maximum height actually. This height here was given to make us lose sight of the question, which actually worked for a while. Because a bullet fired vertically upward from a gun held, the gun was held 2 meters above the ground. So that does not mean that the bullet reached its maximum, the maximum height of the bullet was 2 meters. Do you understand? So now that's what I got it wrong first. So what we actually only have is what? 4 time as what? 4 seconds, and gravity as what? 10 meters per second. Now, let me just quickly use this explanation to explain what is going on here. So now, as you can see, it says maximum height here is supposed to be what? UT plus what? Half AT squared, right? So I know what U is. I don't know what U is, so I have it as 4U. Then I know what T is, and after all the resolving, what we end up with is what? 4U plus 80, right? So that's 4 squared, 4 times 4 is power 2. That's 16. 16 times 10 is 160. Then 2 in 160 gives me what? 80, right? So I have 4U plus 80. Okay. So my thing is, this is not a solution, right? This is not a solution. So what we now did again was to what? Put in another equation. So using this equation, v squared equals to u squared plus what? 2as. And then because we're calculating it with respect to the fact that it's reaching what? Maximum height. So and at the maximum height, the final velocity is what? 0. So that takes care of that for us. So we now have what? U squared plus what? 2as, right? So now, if you notice earlier, we calculated what? Maximum height as what? 4u plus 80. Okay? So you now have what? U squared plus what? 2 times 10, which is 2 times addition due to gravity. Then times 4u plus 80. And then when you expand this bracket, what you end up with is u squared plus, so 2 times 10 is 20, 20 times 4 is what? 80u. And then 20 times 80 is what? 1,600. Okay, then you solve it quadratically. What you end up is what? You end up with what? 40 meters per second. So the answer here would be what? C. I hope that makes sense. Yeah, I hope that makes sense. Okay, so one more question before we call it a day. Now look at this. It says an object is projected from a height of 80 meters above the ground with a velocity of what? 40 meters per second at an angle of 30 degrees to the horizontal. If you calculate the time of flight, it's pretty simple actually. So I think we've done this already, if I'm not mistaken. Okay, no, this is another question. So it's pretty simple. The time of flight just means that we're calculating what the total time, right? So let's just use this explanation here. The formula here is what 2u sine theta all over what? Gravity. What is my u? Which is my initial velocity, 40 meters per second. So 2 times 40 times sine 30. Sine 30 happens to be what? 0.5 divided by 10. So I have what? 80 times 0.5 divided by 10. 80 times 0.5 is 40. And then 40 divided by 10 gives me what? 4 seconds. So that means my answer is what? 4 seconds. Okay. So that is it for projectiles for today. So if you guys have any questions on projectiles, just mention it or just signify in the comments below. Do you have any questions, anything that you need explanation more on, or anything you want to go over? Anybody questions on projectiles? Anybody questions on projectiles? So nobody. Okay. No problem. So with that, we've come to the end of projectiles for today. Thank you very much.